बिस्मिल्लाहिर्रहमानिर्रहीम। अल्लाहुम्मा सल्लि अला मुहम्मदिन व अला आलि मुहम्मदिन व बारिक वसल्लिम। रब्बिश्रह ली सदरी व यस्सिर ली अमरी वहलुल उक़दतम मिन लिसानी यफ़क़हू क़ौली। Assalamu alaikum. I am Dr. Umar Farooq. So students, let's recall what we have studied so far. In the lecture number 3, I talked about the classification of matter and described its various types, that is substance and mixture, which are further classified as element and compound, homogeneous and heterogeneous mixtures. But before this lecture, that is in lecture number 2, we investigated about the particles of matter, that is atom, molecule, formula unit and ion. Then the next lectures were the continuity of this very flowchart. So lecture number 4 was a further study of the same flowchart, and we learned how to represent the particles of matter. And last lecture, that is lecture number 5, was in continuation of the previous lecture, in which we discussed about the masses of the particles of matter. So the story still continues. Our today's lecture deals with the masses of particles of matter in gram units. As you know that the mass of an atom, molecule, formula unit and ion is expressed in AMU. But if they are expressed in gram, they are termed as gram atomic mass, gram molecular mass, gram formula mass and gram ionic mass respectively. Each of these quantities is given a special name, that is a mole. So you got this. Mole is the center of my today's talk. Let's draw the complete flowchart up to mole. A substance is a pure form of matter which may be an element or a compound. Their smallest unit may or may not exist freely. If the smallest unit of both element and compound exists freely, it is called a molecule. And if it does not, for an element, it is called an atom, and for a compound, the formula unit. An atom is represented by symbol of element, a molecule by molecular formula, whether it belongs to an element or a compound, and a formula unit by empirical formula. Mass of an atom is called atomic mass, mass of a molecule, the molecular mass, and the mass of a formula unit, the formula mass. All of these masses are expressed in AMU. But if they are expressed in gram units, they are called gram atomic mass, gram molecular mass and gram formula mass respectively. And each quantity is termed as a mole and contains exactly 6.02 into 10 raised to the power 23 number of particles, whatever the particles may be. As I told you that today's talk of mine revolves around mole, so in this very flowchart, I have given two definitions of mole. Can you point out those? Okay, good. First is a collection of 6.02 into 10 raised to the power 23 number of particles is called 1 mole. And the second definition is atomic mass, molecular mass and formula mass expressed in grams is called 1 mole. I hope you understand each and every point. A mole is also called Avogadro's number in honor of the Italian chemist Amadeo Avogadro, who didn't discover it. It is just named after him, as he is the first who gave its idea. Mole is abbreviated as MOL. Avogadro's number is denoted by Na, both capitals, but A is written in subscript. So the atomic mass of an element expressed in gram is called gram atomic mass or gram atom. It is also called a mole. The molecular mass of a molecular element or a compound expressed in gram is called gram molecular mass or gram molecule. It is also called a mole. Similarly, the formula mass of an ionic or network covalent compound expressed in gram is called gram formula mass or simply gram formula. It is also called a mole. Let me give you some examples of gram atomic mass. Atomic mass of hydrogen is 1.008 AMU. If we change its unit from AMU to gram, it is called gram atomic mass of hydrogen and is equal to 1 mole of hydrogen and contains exactly 6.02 into 10 raised to the power 23 hydrogen atoms. Similarly, atomic mass of carbon is 12 AMU. If we weigh exactly 12 gram of carbon, then it is the gram atomic mass of carbon and is equal to 1 mole of it and contains exactly 6.02 into 10 raised to the power 23 carbon atoms. One more example. Atomic mass of sodium is 23 AMU. So 23 gram of sodium is equal to 1 mole of it and is a collection of Avogadro's number of atoms of sodium. Examples of gram molecular mass. Molecular mass of hydrogen is 2.016 AMU, which is of course twice of 1.008, as there are 2 atoms in a molecule of hydrogen. So if we have 2.016 gram of hydrogen gas, then this is known as its gram molecular mass and is called 1 mole of molecular hydrogen and contains exactly Avogadro's number of hydrogen molecules. Similarly, molecular mass of water is 18 AMU. This is the mass of 1 molecule of water, 18 AMU. If we want to have Avogadro's number of water molecules in a beaker, we have to weigh 18 gram of water, which is the gram molecular mass of water and contains exactly Avogadro's number of water molecules. One more example. Molecular mass of sulfuric acid is 98 AMU. Its gram molecular mass is 98 gram, which is equal to 1 mole of H2SO4 containing 6.02 into 10 raised to the power 23 molecules of sulfuric acid. Some examples of gram formula mass. The formula mass of sodium chloride is 58.5 AMU. If we weigh 58.5 gram of sodium chloride, then this is called gram formula mass of sodium chloride and is equal to 1 mole of it and contains exactly Avogadro's number of formula units of sodium chloride. Formula mass of calcium carbonate is 100 AMU. 100 gram calcium carbonate is its gram formula mass and is equal to 1 mole of it and contains Avogadro's number of formula units of calcium carbonate. Similarly, formula mass of potassium sulfate is 174 AMU. Its gram formula mass is 174 gram, which contains exactly 6.02 into 10 raised to the power 23 formula units of potassium sulfate. So, mole or Avogadro's number are units of counting. The other commonly used units of counting are 1 dozen, which is a collection of 12 items. 1 gross, which is a collection of 144 items. Similarly, 1 ream is a collection of 500 items. And a mole is a collection of 602 billion trillion items. In scientific notation, 6.02 into 10 raised to the power 23 or 21 zeros with 602. Let me give you some examples of these units. 12 puppies on the sofa, or you can say 1 dozen of puppies. Similarly, 12 pandas means 1 dozen of pandas. There are 144 eggs in this box, or you can say 1 gross of eggs. 144 pieces of keyrings is equivalent to 1 gross. 144 pencils means 1 gross of pencils. Likewise, 144 pieces of chalk, or you can say 1 gross. Similarly, a packet of 500 sheets contains 1 ream of sheets. Now, 1 mole of each of these substances contains equal number of particles. That is 6.02 into 10 raised to the power 23, whatever the particles are. Note that the mass of 1 mole of each of these substances is quite different from one another, but the number of particles in each sample is same. From this discussion, we conclude that 1 dozen of everything contains 12 items. 1 gross of everything contains 144 items. Similarly, 1 ream of everything contains 500 items. Likewise, 1 mole of everything, I repeat, 1 mole of everything contains Avogadro's number of items. Some interesting facts about Avogadro's number. A computer counting with a speed of 10 million atoms a second would take 2 billion years to count 1 mole of atoms. Another fact is, a glass of water which contains about 10 moles of water has more water molecules than the grains of sand in the whole Sahara Desert. So it's a very huge number. Another interesting example is, the average size of a grain of sand is 1/100th of an inch. To collect 1 mole of sand, you need to spread a layer of sand from Gwadar to Punjab, that is on the whole Pakistan, whose height must be 36 feet 8 inches. That is approximately equal to the height of a triple-story building. Amazingly, this is a very, very huge number. Now it's time to define a very important term, that is molar mass. But first recall that a mole is a collection of 6.02 into 10 raised to the power 23 number of particles. Or in other words, atomic mass, molecular mass and formula mass of a substance expressed in gram is called 1 mole. For example, atomic mass of carbon is 12 AMU. So 12 gram of carbon is the molar mass of carbon. Molecular mass of water is 18 AMU. So 18 gram of water is the molar mass of water. Similarly, formula mass of sodium chloride is 58.5 AMU. So 58.5 gram sodium chloride is molar mass of sodium chloride. Note that the molar mass of each substance has equal number of particles, that is 6.02 into 10 raised to the power 23, or 1 mole of particles. In short, we can say that gram atomic mass, gram molecular mass and gram formula mass is called molar mass. In the word molar, AR means of 1 or of A. So molar mass means mass of 1 mole. Remember students, atomic mass is the mass of 1 atom. Molecular mass represents the mass of 1 molecule only. Similarly, formula mass is the mass of 1 formula unit, and ionic mass is the mass of only 1 ion. All of these masses are expressed in AMU. But molar mass is the mass of 1 mole of atoms, molecules, formula units or ions. its unit is not AMU, rather it is gram per mole, which will be explained later. Students, at the end we need to have mathematical formulas to be used in mass, mole and particle calculations. I'm going to derive these formulae with the help of an example. Molecular mass of water is 18 AMU, but its molar mass is 18 gram. You know that 18 AMU is the mass of one water molecule only, while 18 gram of water has Avogadro's number of water molecules, or 1 mole of water molecules. Let's write these observations. 18 gram of water is equal to 1 mole of water, which contains 1 Avogadro's number, or 6.02 into 10 raised to the power 23 molecules of water. Now doubling the mass doubles everything. Similarly, 3 times 18 is 54. So 54 gram of water means 3 moles of water, and it contains 3 Avogadro's number water molecules. For other masses, note by yourself. So from these observations, we conclude that we use mass to obtain moles, and using moles we can find number of water molecules. So number of moles are obtained by dividing these masses by the molar mass of water, that is 18, to get these number of moles. So number of moles is equal to the given mass in grams divided by the molar mass of the substance. Similarly, number of particles can be obtained by multiplying number of moles with Avogadro's number. These are two important formulae which are used in mass, mole and particle calculations. Note that number of moles can be obtained using any of these formulas depending on the given data. If mass is given, then divide it by the mass of 1 mole, that is molar mass. And if number of particles are given, then divide them by the particles of 1 mole, that is Avogadro's number. Rearranging these two formulas, we can obtain mass and number of particles if number of moles are given. To find mass, multiply number of moles with molar mass. And to find number of particles, multiply number of moles with Avogadro's number. Students must learn these formulae by heart to solve the mass, mole and particle problems. To memorize these formulae, you should draw the following figure on your notebook again and again. Write mass on extreme left, moles in the center and particles on extreme right, and then connect them by arrows. 2 arrows are moving towards moles and 2 are moving away from it. Now moving towards moles either from mass or from particles, use division formulae, while moving away from moles, use product formulae. Now dealing with mass, use molar mass as a multiplying and dividing factor. While dealing with particles, use Avogadro's number as a multiplying and dividing factor. I hope you understand. Finally, the units of molar mass are obtained using this formula. Number of moles is equal to mass in gram over molar mass. Now shifting molar mass to the left hand side and number of moles to the right, we get this. Writing units of both quantities on right hand side, we get gram over mole, or you can say gram per mole. If you have any questions, please don't hesitate to ask. Thank you.